Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss roots of a complex number. As an example, we have to find out what should be the cube root of unity. Let's begin. Using De Moivre's theorem, we can get the roots of a complex number. We have prefer a complex number z is equal to x plus iy. In polar form, we expressed to substitute x is equal to r cos theta, y is equal to r sin theta. That is x axis, y axis. Let a point P having coordinate r theta in polar form, that is the value of r. This is the theta which is known as the argument. Same thing for that of z is equal to x plus iy, that point having the coordinate xy, that portion is y, that portion be x, that portion with the magnitude of z. Therefore, in polar form, we write it as z is equal to r cos theta plus ir sin theta. Taking r as common, cos theta plus I sin theta. Cos theta plus I sin theta, which is equal to e to the power I theta. Therefore, z is equal to r into e to the power I theta. Let it refer as equation number 1, where r is equal to x square plus y square under root. Also, let we take another complex number z dash, which is written in the form of a plus ib. This is another complex number. Then a, let we prefer r cos phi, b r sin phi. As we convert that one to that of polar form, we have to substitute a is equal to r cos phi and b is equal to r sin phi. So z dash change to r of cos phi plus I sin phi. Therefore, z dash is equal to r, that is equal to e to the power I phi. Point out it as equation number 2. Z is a complex number, that is a complex number, and z dash is another complex number. Let we take z, let we prefer z be the nth root of z dash. You have to taking z be the nth root of z dash, that is z dash to the power 1 by n, z dash to the power 1 by n is equal to z. To find out the roots of that complex number, we have to assume that z be the nth root of z dash. Z is a complex number and z dash also a complex number. We write z and z dash in terms of polar form. Hence, z to the power n is equal to z dash, which implies z r into e to the power I theta, r into e to the power I theta to the power n is equal to z dash capital R e to the power I phi which implies r to the power n into e to the power I n theta plus r e to the power I phi. R to the power n, so e to the power I n theta can be written in terms of cos and sin. We write by using Euler's formula as cos n theta plus I sin n theta is equal to r, again e to the power I phi is written as cos phi plus I sin phi. Now r to the power n cos n theta plus I sin n theta is equal to r, here cos phi plus 2m pi, there will be no such change as it is addition of 2 pi plus I sin phi plus 2m pi. Here m is any integer. Now comparing both sides, we get, so r to the power n is equal to capital R, r to the power n is equal to capital R, and cos of n theta is equal to cos of phi plus 2m pi, therefore n theta is equal to phi plus 2m pi. In these two terms we have, and n theta is equal to phi plus 2m pi. Therefore we have the magnitude of z is equal to small r, which is equal to small r is equal to r to the power 1 by n, and here theta basically known as theta, which is known as the argument of that complex number z, argument of z, that is equal to phi plus 2m pi divided by n. These replacements we can introduce to that of respective equation. Hence z is equal to z dash to the power 1 by n, as you prefer, z equal to z dash to the power 1 by n. Substituting these values in place of z dash, that is the values of z dash as r e to the power I phi. Now the terms are written r to the power 1 by n and cos phi plus I sin phi, sorry, okay, that is cos, the replacement of that theta term, the replacement of theta term as cos phi plus 2m pi divided by n plus I sin phi plus 2m pi divided by n. That equation number 3. Here taking as equation number 3, that taken as equation number 4. As we prefer z with the nth root of z dash, so by putting the values of m, we can find out n number of roots here. By putting m is equal to 0, 1, 2 up to n minus 1th term, as it starts from 0, we have the corresponding roots. Then n values give the nth roots of z. So the roots are calculated as putting m is equal to 0, m is equal to 1 up to n minus 1th term. When m is equal to n, then that bracket term converts as cos phi plus 2n pi divided by n plus I sin phi plus 2n pi divided by n, which is equal to cos 2 pi plus phi by n, I sin 2 pi plus phi by n, 2 pi plus theta is equal to cos theta. Here sin 2 pi plus theta is equal to sin theta. So cos phi by n plus I sin phi by n. That value also we get when we put m is equal to 0. When we put m is equal to 0, that term converts to cos phi by n plus I sin phi by n, which is the same as the value for m is equal to 0 also. Therefore, for m is equal to n, n plus 1, n plus 2 up to that produces the repetition of the first n values. Now we using that formula, we can easily evaluate the roots of a complex number by putting the corresponding terms. As m is equal to 0, we have first root, as m is equal to 1, second root, up to so on. If the question given find out the 3 roots, then it starts from 0, 1, 2, 3 like this. Example, later we have to find out the cube root of unity. cube roots of unity. What are the first three roots of 1? Let me prefer x be the cube root of unity then x is equal to 1 to the power 1 by 3, or x is equal to, in place of 1 I write it as cos 0 plus I sin 0 to the power 1 by 3, or x is equal to cos 0, that is cos 2n pi plus I sin 2n pi, value also 0, to the power 1 by 3. As I use that type of format to derive various roots of a complex number. Now, using de Moivre's theorem, so that power is multiplied to that of angle, or x is equal to cos 2n pi divided by 3 plus I sin 2n pi divided by 3. Let me put the values of n as 0, 1 and 2, as we have cube root means 3 number of roots. Putting n is equal to 0, 1, 2, the roots of unity are basically put x when n is equal to 0, we have first root, that is x 0, that is cos 0 1 sin 0 0 is equal to 1. It is the first root. Next, putting here when n is equal to 0, when n is equal to 1, we have x1 is equal to cos 2 pi by 3 plus I sin 2 pi by 3. Or x1 is equal to cos 2 pi by 3 means cos 120 degree, that is minus half, plus I sin 120, that is root 3 by 2, root 3 by 2. That term basically preferred as omega. Here we put omega is equal to minus 1 by 2 plus I root 3 by 2, that is the second root of unity. Next, put n is equal to 2. When n is equal to 2, we have x2 is equal to cos 4 pi by 3 plus I sin 4 pi by 3. Or x2 is equal to cos 4 pi by 3 results minus 1 by 2. Again, sin of 4 pi by 3 results minus I root 3 by 2. When we taking the square of that term, we have that value as minus half minus I root 3 by 2. Therefore, x2 is written as omega square, that is the another root of 1. So, 3 roots of unity as 1, omega and omega square are found out by using the formula of deriving the roots of a complex number. In this way, we derive the cube roots of unity. It is seen that various properties in case of cube root of unities as 1, omega and omega square properties of cube roots of unity. These are the important properties. When we add these 3 cube roots, adding these 3 cube roots as 1 plus omega square, we have 1 value of omega minus half plus I root 3 by 2 omega square minus half minus I root 3 by 2. So, these terms minus half 1, so plus 1 minus 1 cancel out. Next plus I root 3 by 2 minus I root 3 by 2 cancel out. So, we have 1 plus omega square is equal to 0. Next property, the product of these 3 cube roots as 1 into omega square, 1 into omega square is equal to 1, or we say omega cube is equal to 1. Next property, the cube roots of unity represents the vertices of an equilateral triangle whose 3 sides are equal on that of a argand plane. Argand plane means a complex numbers are drawn in such type of plane. If I create that plane, here x are the real axis, y are the imaginary axis. So, the triangles basically formed as the sides as A, B, C. These points A, B, C are the vertices of that equilateral triangle ABC. Here the angle 120, that angle 120 degree, this angle also 120 degree. The points A, B, C, the points A, B, C represent the 3 cube roots such that OA is equal to OB is equal to OC, and measurement of AOB is equal to 120 degree, and measurement of AOC also 120 degree. Where O is the center of the circle with unity radius. This radius is 1 unit. Okay. In this way, the vertices of that equilateral triangle show the cube roots of unity as 1, omega and omega square. This is the cube root of unity is derived in this manner, and the properties of these cube roots of unity as 1, omega and omega square. The addition of these three results 0 and multiplication of these three results 1, and graphically we show these 3 points in an argand plane. Next, some questions related to cube roots of unity. Question number 1, find the value of 1 minus omega to the power 6 where omega is the cube root of unity. The solution, we know 1 plus omega square is equal to 0. The addition of the cube roots of unity results 0. From that expression, we have 1 plus omega square is equal to minus omega. Now, we have to find out 1 minus omega to the power 6. It is written as 1 minus omega square to the power 1 minus omega square cube. 1 minus omega square can be expanded as 1 plus omega square minus 2 omega to the power 3. In place of 1 plus omega square, I write minus omega minus 2 omega to the power q, which is equal to minus 3 omega to the power q, that results minus 27 omega q. Therefore, we have 1 minus omega to the power 6 is equal to minus 27 omega q results 1, as omega q is equal to 1. The product of 3 cube roots results omega q as 1. Therefore, we have 1 minus omega to the power 6 is equal to minus 27. That will be the answer of that given question. Next, question number 2, solve x to the power 4th plus I is equal to 0. The solution, x to the power 4th plus I is equal to 0, which implies x to the power 4th is equal to minus I. In place of minus I can be written as cos pi by 2 minus I sin pi by 2. Here cos pi by 2 0, sin pi by 2 1. Now, which results x to the power 4th. Therefore, x is equal to x to the power 4th is equal to. Now, we have to use the formula to derive n number of roots of that complex number. So, we introduce cos 2m pi plus pi by 2, there will be no such change, minus I sin 2m pi plus pi by 2, where m is an integer. Therefore, x is equal to cos 2m pi plus pi by 2 minus I sin 2m pi plus pi by 2 to the power 1 by 4th. Now, we have to use the de Moivre's theorem here, that power is multiplied within that of angle. We have cos 1 by 4 into 2m pi plus pi by 2 minus I sin 1 by 4 2m pi plus pi by 2 which is equal to cos here taking LCM, 1 by 4 4m pi plus pi divided by 2 minus I sine 1 by 4, that is 4m pi plus pi divided by 2 is equal to cos 4m plus 1 to pi by 8 minus I sine 4m plus 1 into pi by 8. Now we have to find out 4 number of roots. So the values of m for m is equal to 0, 1, 2, 3, that is 1, 2, 3, 4 numbers. We get, putting x1 as 0, we have x1 root as cos pi by 8 minus I sine pi by 8. Next x2 as putting m is equal to 1, we have cos 5 pi by 8 minus I sine 5 pi by 8. Next putting, here put m is equal to 0, here put m is equal to 1, here m is equal to 2. x3 has cos 9 pi by 8 minus I sine 9 pi by 8. When put m is equal to 3, we have x4 is equal to cos 13 pi by 8 minus I sine 13 pi by 8. In this way 4 roots of that given equation is derived. So with the help of this video lecture, we understand the roots of a complex number. That formula is useful to derive the roots of a complex number. Accordingly, the values of m as putted here to derive what numbers of roots are given to that of particular question. As an example, we found out the cube roots of unity as 1, omega and omega square, some properties related to cube roots of unity, and 2 questions related to roots of a complex number. Question number 1 and its solution, question number 2 and its solution. So with this useful and informative notes, let me wind up this session. Thank you.